Hello everyone, welcome to my channel, and this is an educational channel where we take a look at various theories of everything, all-encompassing theories, um, magnum opuses from obscure authors, and other things that you might not know that would benefit your life if you heard about them, but you probably haven't because these things have been suppressed or ignored or, otherwise kept out of your school curriculum or even out of your media viewing. And today is our 354th video that we've done on Dewey B. Larson and his reciprocal system of theory. And Mr. Larson was an engineer who lived in the 20th century and died in 1990, but not before he put out many books on matters of mostly science, chemistry and physics and astronomy, but also some economics and some metaphysics. Including philosophy and religion and psychology and biology. And then some of his followers have even extended his work into other areas. And some of them have revised Larson's work slightly. Some of them, I believe, have stayed within the spirit of the reciprocal system and have done great work toward furthering, the long-term fortunes of the reciprocal system. But the future isn't that bright. There aren't too many people who know anything about the reciprocal system. In fact, I have never met another person in person that has ever heard of the reciprocal system. So it's probably one of the reasons why I'm trying to put out these videos, because I think it's a great study and I think it's a great theory, a system, and I'd like to get it out there. So I can have at least somebody to talk to. And the basic idea behind the reciprocal system is that we live in a universe of motion. The universe is not made out of matter, not made out of energy or force or anything else, but it is made entirely and exclusively out of motion. In particular, a kind of motion that Larson calls scalar motion, a motion that has a magnitude, but it has no specific direction. A model for that would be a balloon with dots on it. If you blow up the balloon, all the dots are moving away from each other. It's analogous to the expansion of space. All of the dots are moving away from each other, further and further and further apart. And the farther apart they are, the faster they're moving away from each other. But there's no specific direction attached to those movements until you arbitrarily decide that one of those dots is motionless and you assign it as the reference point. Once you do that, then directions are imputed. And so that means that the directions are not the result of the scalar motion, but they are the result of the reference point. And, this is also seen in the clock. The clock is always getting later and later and later, but in no specific direction. And that's kind of the key thing about the reciprocal system, is that motion, as defined by Larson, is the relationship between space and time. And so we just looked at, both the spatial and the temporal aspects of scalar motion, the clock. And we'll be talking about that in more detail a little bit later, but it's what Larson calls clock time and clock space. Time is always getting later and later and later. Space is always getting farther and farther and farther apart, but in no particular direction. And this is kind of the motion that Larson builds his universe out of. Then there is also what Larson calls coordinate space and coordinate time. This is a three-dimensionality. X, Y, Z coordinates of space. We're accustomed to that, thinking of space in terms of three dimensions, volume, and then also three dimensions of time. Because space and time are reciprocals of one another. They do not exist separately. They only exist together in motion. Basically, you can think of motion as a fraction, with space or time as the numerator, time or space as the denominator. You can think of it kind of as a ladder or something, that you have steps on the ladder. At the midpoint is 1. And as you go up the ladder, or you could say to the right, you go 1, 1 is the center, then you go 2, 3, 4, 5, 6. And in the other direction, in the negative, so-called negative direction, you go from 1 to 1/2, 1/3, 1/4, 1/5, and 1/6. And so they balance each other out. And time, if you move in one direction in terms of space, then you have to move in the other direction in terms of time to balance it out. So they always are going to multiply to be 1. So there is kind of just one place on that ladder where time and space are equal, and that is when they are equal to 1. And so when they are equal to 1, you have 1 over 1 equals 1. And for Larson, he calls that unit speed. Now again, the relationship between space and time is motion. And so when you have one unit of space in 1 unit of time, you have a speed of 1, which is, in Larson's estimation, that is the speed of light. And he calls that unit speed. 1 over 1 equals 1. Now, when you move to the right, then you have, when space moves to the right and it becomes 2 units, then time moves to the left and it becomes 1/2 unit. And, so you are, I'm not completely sure on this analogy at this point, but basically, when you have 1 over 1, you have unit speed. If you move in either direction, then you move into one sector or the other. Larson calls these the material sector and the cosmic sector. The material sector is the half of the universe that is moving slower than the speed of light, and the cosmic sector is the sector that is moving faster than the speed of light. And the material sector is really the only sector that's known by legacy scientists. Einstein himself said that the speed of light is the maximum speed of the universe. And therefore, he's excluding the entire cosmic sector, where the speed is faster than the speed of light. And basically, this all comes from what Larson calls the discrete unit postulate. And so space or time come only in discrete units. You have to have a full unit of space and a full unit of time to have anything. if you don't have a full unit of space, you don't have space. If you don't have a full unit of time, you don't have time. And now this gets into a question that I'm having trouble with here with the this number line thing that I was trying to work on here. You still have to have. I guess I would have to take back what I just said about if you move one in one way on the other on the number line, the other one moves the other way, because that ignores the discrete unit postulate. If you move one way on the line, the other still stays at 1. And so if you move to 2, you still have a speed of 2 over 1. I think that, and then if you move in the direction of 1/2, well, that's 1/2 in terms of space, but it is 2 in terms of time. That's how I would think of it, but that might be something that we would look into later. The basic idea is that, there's a boundary in this universe, which is the speed of light. And that boundary is between the material and the cosmic sectors. And you have a material sector where you have atoms and particles and molecules. And you also have cosmic atoms and molecules and particles on the other side of the boundary. And those are known by science as antimatter. And if you, they are identical. The material sector and the cosmic sector are the same. They are reciprocals of one another, except that you have to reverse the roles of space and time. So in the material sector, you have coordinate space, 3 dimensions of space, and you have clock time. The clock is always getting later and later and later. But in the cosmic sector, you have coordinate time, 3 dimensions of time, and clock space. Space is always getting farther and farther and farther apart. Okay, that's basically Larson's first postulate. The universe is made entirely out of scalar motion, which comes in 3 dimensions, in discrete units, and has 2 reciprocal aspects, space and time. And then his second postulate, he only has two physical postulates, and that is the universe is made out of, the universe conforms to the relations of ordinary mathematics. Its magnitudes are absolute, and its geometry is, well, first, Larson says its geometry is Euclidean, but Dr. Bruce Peret, one of his revisers, says that the geometry is projective. And we're going to be looking at one of the articles that was written by Dr. Bruce Peret here that's called Dimensions and Displacements. And I started this article a couple days ago, so this is the 3rd installment. So if you want to go back to the beginning, you probably want to go back 2 videos. But we are about to start on a section of this paper that is called The Concept of the Clock. So this is going to get into this idea of scalar motion. The concept of the clock. In a universe of motion, everything is motion, and that includes the clock. Granted, conventional thinking says the clock is just time, but with 2 sectors of motion, there are also 2 aspects of the clock time and clock space. Taken together, the relation of space to time or time to space is motion. So the clock is motion with aspects of space and time, just like any other motion in the reciprocal system. Where the confusion comes in is what the clock represents. If we examine how we use clock time, it is normally in relationship to either duration or speed. It took 5 hours to unload that truck, or that car is going 45 miles per hour down the road. In both cases, time is related to space. Moving boxes a distance for a specific duration of time, or a distance per a duration. The clock is therefore the standard device we use to measure change, or as Larson would put it, the datum of measurement. The only datum in the reciprocal system that is that of unit speed, from which all motion is measured. It is from this unit motion datum that displacements are made to create structure. But the default at-rest condition of the universe is to move at unit speed, the speed of light. Larson refers to this motion as the progression of the natural reference system. So in Larson's progression of the natural reference system, this is always occurring. This is the background motion of the universe. This is the at-rest position of the universe. So in a universe of motion, we always have motion, and it is the background and the state of rest of the origin, the ether, the reference point, the reference system, and the natural datum. And, that makes sense. In a universe of motion, there is always motion. And that motion can be modified through displacements. This unit speed is what we call the clock, our datum of measurement. A common misunderstanding is that the progression, the expansion of the universe moves with the tick of the clock in both space and time. This is incorrect. The progression is the tick that moves everything else, because the progression does not move relative to itself. It stays fixed, like the end of a tape measure. Each discrete unit of the progression is a tick of the clock. When we make use of clock functions, we normalize that aspect, clock time or clock space. That simply means that we take a ratio, like driving 300 miles in 5 hours, and reduce the denominator to unity. 300 miles in 5 hours is normalized to 60 miles per hour, a speed. It took you 6 hours to write 3 book reports. Then you are working at a rate of 2 hours per report. We then use these normalized rates to predict future events. If you had 10 book reports to write at 2 hours per report, then you're looking at 20 hours of work. In many scientific applications, the normalized component, the denominator of a ratio of motion, is just ignored because it is unity. The ratio of s over 1 simply becomes s, a distance, rather than a speed. When examining conventional scientific processes, keep a watchful eye out for this omission. Now, when you're talking about discrete units, the natural unit of space is 4.56 times 10 to the minus 8 meters. And the natural unit of time is 1.52 times 10 to the minus 16 seconds. So those are the discrete units. You have to have a full unit in order to have anything. And if you have 1 unit of space in 1 unit of time, you have the speed of light. All other scientific quantities are also relations between space and time, or time and space. But they, time and space can come in multiple dimensions. And so you can have relations such as acceleration, which is space over time to the second power, or force, which is time over space to the second power. Or you can even go all the way up to matter. Matter is time to the third power over space to the third power, or even density, time to the third power over space to the sixth power, because density is mass over volume. So you have time to the third power over space to the third power over space to the third power, mass per volume, density. So it kind of works like that, and it works as a great check on your system to see if you've done your, done your equation correctly, if your equation is dimensionally consistent. Because you're only using two variables here, time and space, as opposed to like the MKS system where you have time, space, and mass. Here you get rid of the mass, and that gets rid of 98% of the confusion. Okay, this section here is called displacements. A displacement is a measurement of how much something changed from a known point. In the reciprocal system, that point is unit speed, the speed of light. The notation for particles and atoms use displacements rather than the ratio of speed, because it is actually that displacement, or the delta, that defines the atomic properties. Displacements are simply the difference in one aspect of motion from unity. So if you want to have a two-temporal displacement, you basically have, you start with unit speed 1/1, and you move 2 units in a direction from that number line, on that number line. So a displacement of 2 would be moving, from 1 to 2 to 3. That would be 3. That would be a spatial displacement of 2. If you move in the other direction, you're moving in the temporal direction, and you would move from 1/1 to 1/2, and then to 1/3. So 1/3 would be 2 units of temporal displacement. So that's how you are measuring. You're measuring from that reference point, that 1/1 unit speed reference point. Is it plus or minus that? If it's plus, you're moving in the spatial direction. If it's minus, you're moving in the temporal direction. And then you have to count off how many steps on the rung of the ladder or the number line that you are moving. And you only can move in a discrete number of steps. You can't move 4.5 steps or 3.6 steps. You're only moving integers, 1, 2, 3, 4, and so if you are moving a temporal displacement of 4, you move from 1/1 to 1/2 to 1/3 to 1/4 to 1/5. That is a temporal displacement of 4 to get from 1/1 to 1/5. A displacement can either be in space or in time. In the reciprocal system, a spatial displacement is distinguished from a temporal one by placing the number in parentheses, like an accountant would for a negative number. So 2 would be a temporal displacement of 2, speed of 1/3, as compared to 1/1, and 2 in brackets or in parentheses would be a spatial displacement. And there it would be a speed of 3/1. It seems like it would be the reverse of that, but I think that's not really that important. Okay, I think we're going to leave it off here. In the next section, he's going to get into atomic rotations, and kind of that'll be the end of this paper. The last little part here, where he's talking about atomic rotation and how this system fits into Larson's formulation of the periodic table. Okay, well, sorry for some of the confusion there. I'm learning this at the same time you are. I just have a little bit of a head start, or in some cases a lot of a head start, but maybe, I'm a little bit remedial on this and some of the concepts don't stick. But basically, that number line concept is correct, but you only move in one direction. You don't move in two directions. The basics of the reciprocal system are that, the basic way to learn it is that you have to basically suspend your disbelief, because he's going to hit you with a lot of concepts that are foreign. A lot of concepts that you could debunk circularly if you, mobilized your scientific knowledge, so-called knowledge that you got from high school or college science, or graduate school level science. And if you're assuming that those are correct, you can easily, refute the reciprocal system based on that circularity. But if you are really coming to it with an open mind, then you have to kind of check that at the door, and you can refer to it later, but you need to get the whole picture of Larson's structure before you start rejecting things. So you have to suspend disbelief long enough to at least give the reciprocal system a proper hearing. Okay, well, have a great day. Thanks for tuning in.